Hello, welcome to the session on queue operations in data structure. First question, a linear list of elements in which deletion can be done from one end and insertion can take place only at the other end is known as. The answer is queue, as the linear list of elements in which deletion is done at front side and insertion at rear side is called queue. In stack, we'll delete the last entered element first. The second question, the data structure required for breadth first traversal on a graph. The answer is C, Q. In breadth first search traversal, starting vertex is first taken and adjacent vertices which are unvisited also taken. Again, the first vertex which was added as an unvisited adjacent vertex list will be considered to add the further unvisited vertices of the graph. To get first unvisited vertex, we need to follow first in first out principle. Queues uses the first in first out principles. The next question, a queue follows. The answer is, as you know, it's a first in, first out principle. Next question, circular queue is also known as. The answer is A, ring buffer. Circular queue is also called as a ring buffer. Circular queue is a linear data structure in which last position is connected back to the first position to make a circle. It forms a ring structure. Fifth question, if the elements A, B, C and D are placed in a queue and are deleted one at a time, in what order will they be removed? In queue is based upon the first in first out principle. The answer is A, B, C, D. Queue follows first in first out approach, first in first out approach. So the order of removal elements are A, B, C, D. Sixth question, a data structure in which elements can be inserted or deleted from both the ends but not in the middle is. The answer is DQ. In DQ, we can insert or delete the element from both the ends. In Q, we'll follow the first in first out principle for insertion and deletion of the elements. So answer is C, DQ. And elements with the least priority will be deleted in a priority queue. Seventh question, a normal queue if implemented using an array of size max size gets full when. Answer is A, when rear equal to max size minus 1, there will be no space left for the elements to be added in the queue. Thus queue become full. Queues serves a major role in. Answer is C, simulation of limited resource allocation. Simulation of recursion uses stacked data structures. Simulation of arbitrary linked lists uses linked lists. Simulation of resources allocation uses the queues, as first entered data needs to be given the first priority during the resource allocation. Simulation of heap sort uses heap data structure. So the answer is C, simulation of limited resource allocation. That is the major role of queues. Which of the following is not the type of queue? The answer is B, single-ended queue. Queue always has two ends. So Single-ended queue is not possible, not the type of queue. Which of the following is an application of queue data structure? Answer is all the above. Queue is used when things don't have to be processed immediately but have to be processed in, first out order like breadth-first search. This property of queue makes also useful in following kinds of scenario. When a resource is shared among the multiple customers, example include CPU scheduling, disk scheduling. When the data is transferred asynchronously, data is not necessarily received at same rate as sent between the two processes. So the answer is D, all the above. When the resource is shared among the multiple consumers, when the data is transferred asynchronously, and load balancing. How many stacks are needed to implement a queue? Consider the situation where no other data structure like arrays, linked list is available to you. Answer is 2. A queue can be implemented using two stacks. Let queue to be implemented be queue and stacks used to implement queue be stack 1 and stack 2. So queue can be implemented in two ways. How many queues are needed to implement a stack? Consider the situation where no other data like arrays or linked list is available to you. Which of the following is true about linked list implementation of queue? Linked list implementation of queue. Answer is both. A push operation if the new nodes are inserted at the beginning of linked list, then pop operation nodes must be removed from the end. In push operation if the new nodes are inserted at the end, then pop operation node must be removed from the beginning. To keep the first in first out order, a queue can be implemented using linked list in any of the given two ways, that is both A and B. Suppose a circular queue of capacity n minus 1 elements is implemented with an array of n elements. Assume that the insertion and deletion operations are carried out using rear and front as array index variables respectively. Initially, the rear front equal to 0. The condition to detect a queue full and queue empty are: first one, full means the rear plus 1 mod n equal to front, empty rear equal to front.